Okay, we're back. This is Techmath1. We're looking at review for chapter 11, 12. This is part 2. So we're picking up on number 11 on the review. And that says find D, find side D. So we have to decide which one of these we're going to use, sine, cosine, or tangent. So SOHCAHTOA is a way to memorize. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And remember, here's the 90-degree angle, so this is the hypotenuse. So the 529 is the hypotenuse. They gave us the 36 degrees here. They want us to find this, so we're looking at opposite and hypotenuse. Opposite and hypotenuse are, that would be sine. So if we said the sine of 36 degrees, which we can do in our calculator, make sure you're in degree mode. Hit mode and go click down until you see radians or degrees and put it on degrees and hit enter, and then second and quit. And so you got to make sure you're in degrees. So sine 36 degrees is equal to D over 529. And so that ends up to be a pretty easy, right? Cross multiply and solve. It's a proportion. So that's over 1. So we cross multiply. So D is equal to 529 times the sine of 36 degrees. You pump that in your calculator and round to what they tell you. So number 11 is 310.938, and then they want it to the nearest whole number, so 311 is side B. Okay, let's look at this one. They want us to find angle D, this angle, and we have, what do we have? We have adjacent, this would be the opposite, this is again the hypotenuse. Side opposite the 90 is the hypotenuse. So in reference to this angle, this is opposite, this is adjacent. So we have adjacent and hypotenuse. Adjacent and hypotenuse is tangent. So we're going to say the tangent of angle D is equal to 48.6. Oh, wait. No. We don't have opposite, and we're not doing tangent. We don't have opposite and adjacent. Oh, silly. That's okay. We got an eraser. We're okay. So look, we have adjacent and hypotenuse. I even wrote down the word hypotenuse. I'm going to stress that you identify the hypotenuse. So we have adjacent and hypotenuse. Adjacent and hypotenuse is cosine, not tangent. So we say the cosine of D is equal to 48.6 over 65.7. Silliness. I wrote down hypotenuse. Okay, so adjacent hypotenuse. Now, how do I put this in my calculator? Well, that is the arc cosine. That's cosine with a little -1 on it. So you hit second, and cosine, and it'll bring up this, the arc cosine. And then you type in 48.6 divided by 65.7. and parenthesis, and then hit enter. And that will give you the angle. And so the angle given is 42.29. And so we want it to the nearest degree, so 42 degrees. All right. So let's look at this one. We have to be clever about this. They give you this little side is 60. That means this little side is 60. And so we're going to redraw this triangle. They want me to find J. They gave me this is 41 degrees. This is 90 degrees. And so now if that much is 60 from there to there, you take 230 minus 60. And that'll be the remainder, right? That'll be 170. So this right here is 170, this length. It has to be, because if this much is 60 and the whole thing is 230, then that's 170, because 60 plus 170 is 230. Now, why did we do that? Well, because we want the triangle. So now, what are we working? We have opposite and again hypotenuse. So opposite and hypotenuse is sine of 41 degrees is equal to 170 over j. We cross multiply and solve. Again, we've done these already, where at the end of the day, the j goes up here and the sine 41 goes down there. I'll show my work. We'll cross multiply. 1 times 170 is just 170, and then divide out the sine 41. But in the past, I've had Techmath students say, hey, do I have to show all that? I know they just switch spots, so I just put the j there and the sine 41 there. That's fine. You can do it that way. And then you divide and round it. So that comes to 259.123. So we'll call it just 259. Okay. This one, again, they gave us a picture of the whole bottom is 37, and the length, the height is 28, and it's an altitude, so there's a 90 degree, and then they want us to find this angle, angle K. So first, let's redraw it. So it just looks like a single triangle, a right triangle. Half of 37 is 18.5. And they gave us the 28, and this is K. So what I did, I just redrew that right there, so it looks like our normal 90-degree triangles, okay? And so we got opposite and adjacent, no hypotenuse. Finally, we get to get tangent into the mix here. Tangent of K is equal to 28 over 18.5. And now we do the arc tangent. That is second tangent. It'll pop a little -1 on there. And 28 over 18.5. We do not call it the inverse tangent. We call it the arc tangent. The inverse of tangent is cotangent. It's got a thing. So this is called the arc tangent. You're asking what angle produces this ratio and for tangent. And so that turns out to be 56.5 degrees, so we'll call it 57 degrees. They want it to the nearest degree. Okay. All right, let's keep going. 15. So we got 15, and that is find r to the nearest hundredth, and so they give us a right triangle. They tell us this is 2.18 inches, they tell us this is 24 degrees, and they tell us this is r. So again, this is opposite and adjacent, not hypotenuse. So we don't have the hypotenuse, so it's not sine or cosine, it's tangent. So the tangent of 24 degrees is equal to 2.18 over r, okay? Opposite over adjacent. And now we solve for r. So again, when you cross multiply and solve, it ends up where r is equal to 2.18 over the tangent of 24 degrees. Because you cross multiply and then you have this, r is equal to tangent 24 equals 2.18, and then you divide by tangent 24. And that's how we got here. And I just clicked that into the calculator, and they want it to the nearest hundredths. Oh, so this is a little bit of a tricky one, 0.89636. So hundredths place is there, so we look at that, and that's enough to bump it up, but it's a 9, so we get 4.90. I mean, not incredibly hard, but a little, made you think a little bit about rounding. Okay, 16. We've got another 90-degree triangle. And this is 65, 80, and this is 76, 80, and this is H, and they want me to find the angle H, find angle H. And so we have opposite and hypotenuse. Hypotenuse is always the side opposite the 90, hypotenuse. And so opposite and hypotenuse is sine. So the sine of h is equal to 6580 over 7680. And so that means h is equal to the arc sine, second and then sine, and it'll be a -1 on it. 6580 divided by 7680. And then you hit enter and it'll kick out 58.9. And they want it to the nearest degree, 59 degrees. All right. 17, I'm going to have to erase the whole board because that is a tough one. They want you to find the shaded area of a kind of weird picture. So they give you this rectangle. But inside the rectangle, you've got these kind of crossing triangles, and it doesn't even go to there though, does it? It doesn't quite connect like that. Here, let me redraw it, sorry. It is a triangle, and then that is exactly symmetric to the top triangle. So these 4 triangles, this one, this one, this one, and this one are all the same, okay? So we've got 4 equal triangles. They gave you this is 50 and this is 40 centimeters, and this is the shaded area in there. So they want you to find this shaded area. So it's a bit tricky because we've got to find the area of the triangle, and wait, they also gave us, they gave us this side is 30. So the length of that is 30. So that's 30, this is 30, this is 30, this is 30. So all of those are 30. Well, swell. So what we're going to do is we're going to drop that altitude right there. We'll call it h. And this is 30, and this is 25, because if the whole thing is 50, half is 25. So this is 25 and this is 25. Okay, that whole thing is 50, but we just split it into 2 pieces. All right, so now we use the old noodle. We want to find this. Given this and this, that's going to be Pythagoreans Theorem. So h squared plus 25 squared equals 30 squared. H squared plus 625 is equal to 900. And then subtract off the 625. And then h squared is equal to 275, and then you take the square root of that, and that is approximately 16.583. Now, why did we do that? Well, because we want the area of this triangle, and then we're going to take it times 4 because there's 4 equal triangles. This one, this one, this one, and this one, and we're going to subtract it off of the big from the area. So let's find the area. 40 times 50. That's the area of the entire rectangle. 2,000. But then we find the area of this little triangle, just this little triangle. We've got the height and we've got the base. So area of a triangle is 1/2 base times height. The base on this one is 25. The height on this one is the 16.583. Okay, so that's the area of just one single little triangle. And so we find that, and then we're going to multiply it by 4. So wait, I don't think I found it individually. I'll find it individually for your notes here. So it is 0.5 times 25 times 16.583. That is 207.2875. But that's just this area. So we've got 1, 2, 3, 4 identical areas. So we're going to take this times 4. And that's the unshaded area. And we'll subtract it off of the 2,000. So times 4 is 829.15. and then subtract that from the 2000. And we get 70.85, and they want it to tenths only. So yeah, if you wanted to, I would accept either. The book has this 0.8, because if you don't round, if you keep the whole thing and then, you know, work it, this would end up being a 4 something, 4.9 instead of a 5. So this is fine, or this is fine. I rounded, so that is round off error. So if you made it that, I'd still give you full credit. It's fine, within tenths. That's going out to thousandths place in your calculations. Here, I obviously went out a little farther. So either one would be accepted. But that's a tough problem, right? We had to find the area of the whole rectangle and then subtract off these tiny little triangles. And we had to use Pythagoreans Theorem to find the height of the triangle. So that's pretty tough. And then again, 18, 19, and 20, the rest of the problems on this page are pretty easy. It's just sine, cosine, and tangent. Do you know your sine, your cosine, and your tangent? They give you a picture. So 18, 19, and 20. They give you the sine of x, the cosine of z, and the tangent of x, given this picture, where x is down here, angle y is up there, angle z is right there, little z, little x, little y. And so now sine of x, so that's here, and we got the 90-degree angle right there. So this is the hypotenuse. So if I'm on x, opposite is there, hypotenuse is there, that's always the hypotenuse opposite the 90. So x over y. Cosine of z, so they switched it here. Cosine is adjacent over hypotenuse, so x over y again. And then the tangent of x, we're back to this angle. Tangent is opposite over adjacent, x over z. So what you have to get into your head is that opposite and adjacent are relative to where you are on the triangle. So if I'm on x, then this is opposite and this is adjacent. If I'm on z, then this is opposite and this is adjacent. That's how both of these ended up the same answer. They asked for the sine of x, opposite over hypotenuse, and the cosine of z, adjacent over hypotenuse. So it's relative, opposite and adjacent are relative terms based on what angle you're on. Hypotenuse is always the hypotenuse. That never changes. All right, we'll do one more video with the law of sine, law of cosine.